What's going on, everybody? Mr. Diamond, and today I have forgotten my webcam, as you can see by the lack of information or picture that is down here. But we're going to be going through alkane naming. Now, for alkanes, if you remember, alkanes are hydrocarbons that only involve single bonds between carbons. If there's any double bonds, any triple bonds, it is no longer considered an alkane. We use prefixes to determine the number of carbons that make up a chain. And these are going to be slightly different than the prefixes you probably remember from chemistry, but you will still get to use that system. You just won't get to use it right away. So for one carbon, or if it's just one carbon, we call that a methyl. For 2, it's an ethyl. 3, it's a propyl. 4 is butyl. 5 is pentyl. 6 is hexyl. 7 is heptyl. 8 is octyl, 9 is nonyl, and 10 is decyl. And these are both can be used for groups sticking off of carbons, as we'll talk about later, but also give you the base of the word you're talking about if you're talking about a base chain. So, for example, a 2-alkane chain would be ethane. You'd kind of combine the two pieces together. So just like naming in regular chemistry, we change the ending. So if it's only a single bonded carbon, we call this one, for example, this is a methyl, because it would just be a single carbon, but it is in an alkane. It is the base of an alkane because there's only single bonds. There's only one carbon, so there is by definition no double bonds and no triple bonds. So we would call this a methane molecule. So I could also then ask a question of draw the skeletal structure for pentane. So if we look back here, pentyl means that it has 5 carbons, and then ane means there's only single bonds between them. So you would just draw 5 carbons attached to each other. And then we can do the opposite here. So here we have a 1, 2, 3, 4, 5, 6, 7 carbon chain. That 7 carbon chain, if we go back, 7 is hept, not sept. Sept is a common mistake here. 7 is probably the case where people make the most mistakes. These first 3 are a little weird. Our first 4, methyl, ethyl, propyl, butyl. But then 7, other than those, is the ones that gets messed up the most. So this is a 7 carbon chain. 7 carbons with only single bonds would be heptyl, plus alkane is heptane. Okay, now, that was probably pretty straightforward and pretty easy, but in reality, most molecules we work with aren't going to be that simple. So now let's actually explain some of those functional groups that I had you make flashcards for last week. We use these as a modification for existing molecules, and then the key to remember here is that R is used to represent some other thing. It's not a hydrogen. There is some other carbon chain or other group attached on this location. It's going to come up in a bunch of these. So alkenes, pretty much the same as alkanes. You just change the endings. So for example, in this case, this is propane, because it is a propyl, methyl ethyl propyl, with only single bonds. But this one would be propene, because it has an E ending, because it becomes an alkene in this case. Then we have alkynes. Works pretty much the same way. You just change the ending again. We'll talk more about like how this actually naming comes to be later. But so here is butane, methyl, ethyl, propyl, butyl. 1, 2, 3, 4 is for butyl groups. And then it's an alkane in this one, so it's butane. This one here as an alkene because it's a double bond, so that's butene. And then this one has a triple bond, so this would be butine, or butine. You could probably also pronounce that butene, but you would want to make sure you spell it with a Y. This is also not very likely to exist, so that's part of why the name on this one is kind of weird. Okay, then we also have arenes. Arenes are any compound with an aromatic group attached, usually benzene. We won't get more specific for the purposes of this class, so really just look for benzene. You can know that these are either aromatics or arenes if they are these ring structures that have alternating double bonds. I would just expect you to be able to identify that this is benzene. Now, if any of this location, if any of these were not double bonds, if it was not alternating double bonds, so like there could be a double bond here, here, and here. That would be the same thing. But if there was like an oxygen here, or if there was a double bond, and then there was no double bond on this side, there is not a benzene ring. It has to be a 6-carbon circle or hexagon with alternating single and double bonds. Notice the prefix is different in this case because alk is used for only carbon structures without aromatics. Alk and R are the two prefixes used depending on if it's an aromatic or if it's a non-aromatic compound. Okay, now we're going to kind of get into just examples involving all of these. So again, alk means non-aromatic carbons, and halides is coming from halogens. So alkyl halides are any alkane or alkene or alkynes that have a halogen group attached to it. So in this case, this is methyl chloride, and that would be an alkyl halide because it is a methyl group, and then there is a chlorine attached to that methyl group. And then this here would be ethyl bromide because it is a 2-carbon chain, so that's methyl ethyl attached to a bromine. So notice the ending goes from, because it's a halide, we change chlorine to chloride and bromine to bromide. Here we have an alcohol and a thiol. Alcohol is an OH. Thiol is an SH attached here. They're in the same group, so they look a lot alike in different example problems. But for this class, I'm not really going to get to thiol that much. It's just not common enough for me to have to care about you knowing at this point. Other than just knowing it is a functional group, and that is its name, we won't actually get into naming involving it. So here we have 2-carbon chain is ethyl, and then this is an alcohol group attached to it. So this would be ethanol. It would be an ethane molecule. It would be ethane, but it has an alcohol, so we change the ending to OL. And this would be methyl ethyl propyl butyl, and then it has a thiol group attached to it, so it would be butane thiol. You don't change the ending for thiol, you just kind of tack it on to the end of whatever you're talking about. Then we have amines. Amine just means a nitrogen bonded to at least one non-carbonyl carbon chain. I've brought that up a couple times now. I think I haven't actually explained what it is yet. I'll explain in more detail what it is. For now, if you just notice, it's attached to a carbon that it's just in one nice straight chain. So this is 1, 2, 3, 4 methyl ethyl propyl butyl. This one has an amine. It doesn't have to have 2 hydrogens attached to the nitrogen. There could be other things kind of going off of it in a structure, but it just needs to not be attached to a carbonyl carbon chain. So in this one, this would be a butane attached to an amine. This one we do change the ending. It goes from butane to butylamine. Now, for example, these would also be amines because they are both nitrogens bonded to non-carbonyl carbons. The short version of carbonyl carbons is carbonyls involve double bonds to oxygens. So these are all single bonded to carbons. This one is single bonded to 2, and this one's single bonded to 3. All of these are still amines because there is not that double bonded oxygen right next to it. Nitrogen with double bonds could also be considered amines. So if this was nitrogen double bonded to a carbon on one side, that would also be considered an amine. So this one is diethylamine, and this is triethylamine because there's 1, 2 ethyl and 1, 2. So there's 2 ethyls on this one, and there's 1, 2, 1, 2, 1, 2, 3 ethyls on this one. Okay, ethers are an oxygen bridge connecting 2 carbon chains. So there can be whatever, we can have an R group on each of the other sides. So back in that picture, it just usually had like a carbon chain and then an R group. Basically, there just has to be stuff over here. There can't be an OH, because if it was an OH, it would be alcohol. The fact that it's in the middle of something is what makes it an ether or an ether. The sides don't have to be identical. Just think that it's an oxygen with something on either side of it. So this would be dimethyl ether because it's 2 methyls being bridged by an oxygen. This is an ethyl methyl ether because there's an ethyl on one side and a methyl on the other side being bridged by an oxygen. And then finally, this is a nitrile. I said that double bonded nitrogens were still considered amines, but if it is a triple bonded nitrogen, that implies that it's at the end of a carbon chain, and that means it is a nitrile. they're pretty much impossible to be embedded inside of a molecule. They'll have to either be poking off the side or at the edge of the molecule you're talking about. So this would be 2 carbons, that's ethyl, and then it's got a nitrile group attached to it, so it's ethyl nitrile. The common name for this one is acetonitrile. So if you've ever heard of that term, this is the structure of that molecule. Okay, so I mentioned it a couple times that carbonyl carbons are important. Carbonyls are functional groups containing, or carbonyls are in a functional group if there is a carbon, so there would be a carbon right here, double bonded to an oxygen. Carbonyls are incredibly important because they have a whole lot of electrons up here on the oxygens, and they have a whole bunch of electrons pent up in the pi bonds that are forming as around the sigma bond in this double bond. And that means that they are very likely to have some sort of reaction occurring. And depending on what is on these other sides here will tell us what type of thing we're actually dealing with. If this was a hydrogen and a carbon chain, that's one thing. If this was 2 carbon chains, it's another thing. If it's a carbon chain and an oxygen, it's another thing. If it's a carbon chain and an alcohol, it's another thing. If it's a carbon chain and an amine, it's something else. So that's why there's a lot of these are really just, a name for something and then a name for something if it's also next to one of these, if it's adjacent to a carbonyl. The reason they're so different, like I mentioned, is their electrons, because oxygen is so electronegative, and the pi bond, there's just a ton of electrons floating around this area. That leads to a very strong partial charge on the oxygen and a very strong partial positive charge on the carbon, and this can kind of direct the flow of electrons. This will make more sense if we have enough time to actually get to it this year. We didn't have enough time last year. I would not be surprised if we don't have enough time to get to it this year. Okay, so the first type is, what if that carbonyl on one side has some carbon chain, can be however long it needs to be, and then the other side is a hydrogen. There's just nothing on the other side. In that case, that is called an aldehyde, a carbonyl carbon attached to an R group and a hydrogen. Notice we count the total carbons for the prefix still. So it's 1, 2, 3, methyl, ethyl, and then propyl would be 3. But we change the ending to, instead of propane, this is propanal. The propyl group with a carbonyl carbon on the end. The ending is an Al instead of an E at the end of the compound. Next, we have an acid or an acyl halide. Both of those work. Some places will use one or the other for the names. We're probably going to stick with acid halides. Acid halides are a halogen attached to a carbonyl carbon. So there's a carbon chain on the other side, and then there is a halogen. It could be fluorine, chlorine, bromine, or iodine. So this one would be propanoyl fluoride. Propyl alkyl group with a fluorine that's attached to a carbonyl carbon. So the oil instead of the E ending, and then you just add the name of the halide. Amides or amides, again, you'll hear them different ways, and it actually really depends on what the word you're talking about. It's whichever one's easier to pronounce is usually the way it actually works. If there is an amine group attached to a carbonyl carbon, it is no longer an amine, is an amide. There are, like I said, a lot of names of pronouncing it. So in this one, I would call this pentanamide or pentanamide. It depends on, again, wherever you're from. Whichever or whoever you have as your teacher will kind of influence which one you hear more often. In this case, it is a 1, 2, 3, 4, 5 carbon chain. So that's penta. And then amide, there's a nitrogen group attached to a carbonyl carbon. So a pentyl alkyl group with an amine attached to a carbonyl carbon, amide instead of an E ending. This would be pentane, but instead it's pentanamide. Then we have a carboxylic acid. This is if one side is a carbon chain and the other side is a alcohol or is an alcohol group. So in this case, we have 2 carbons. That's ethane or an ethyl group. So, but this time the ethane, instead of being an ethanol, if it would just had an OH, that would be its alcohol name. This also has a carbonyl carbon. So it actually becomes an ethanoic acid. So this is ethanoic acid, aka vinegar. This is actually ethanoic acid is the more correct name in organic chemistry for acetic acid. Now, if one of those sides is an R group and the other side is an ether and has the oxygen bridge, then we would call that an ester. These last two are a little more complicated on the naming, so we're not going to really worry about the namings for these. Esters are just carbonyl carbons directly attached to an oxygen bridge. It could be on either side. It doesn't matter. So the way that you would name these, we're really not going to get into them in this class, but just so you've seen it, you name the group furthest from the carbonyl. So in this example here, the carbonyl is here, so the group furthest from it is this one. That's methyl ethyl. So it is ethyl because there's 2 carbons. Then you name the group on the side of the carbonyl with an anoate ending. So this is 1, 2, 3 methyl ethyl propyl. So this would be instead of propane, this would be propanoate. Ethyl group opposite a propyl group that has a carbonyl carbon directly bridged by an oxygen. Okay, ketones are like aldehydes, except they actually have a carbon chain on both sides of the carbonyl carbon. They end in -one instead of -e, and then we're actually going to be having to indicate where it is located, so we'll end up using in numbers. You'll notice that in all the other examples we did, all of the stuff that we were talking about, the amines, the amides, all of that stuff was always at the very, very beginning of our molecule. These we can't put at the very beginning. So like this one is 1, 2, 3, 4, 5 carbons. That's pentane. But then at position 2, we have a ketone. So we change the ending to -one or -anone, and then we add in the number 2 to indicate that at position 2, there is a -one group or a ketone group on this pentane molecule. This one would be 3-pentanone because it's at position number 3, a pentyl group, 1, 2, 3, 4, 5, with a carbonyl carbon on the 3rd carbon. So I'm going to have you pause the video for a moment and go ahead and try to see if you can identify all of the functional groups in this picture. I'll give you a moment. You should have paused it by now. If you haven't, well, I guess you're not going to pause it, so I guess I can go ahead and go. Let's go ahead and identify the functional groups for all of these. Okay, so the first one on the left, easiest thing that we can get out of the way is there's a benzene here, there's a benzene here. You can call that benzene, you can call that an aromatic, you can call it an arene. Any of those are going to be okay. Then we're going to look for carbonyl carbons. That's usually the next best step to do. So this is a carbonyl carbon that is right next to an oxygen. So this would be an ether, except there's a carbonyl. So instead it is actually an ester. So I would circle these rings for the benzene, for the arene, and then you would circle this chunk right here. That piece right there would be an ester. Now this one here would be an ether. It is attached to a carbon that's double bonded, but that double bond isn't to an oxygen, so this is not a carbonyl carbon. So we would just call this an ether, because there's something on either side of this oxygen. And then the only thing left that's not a carbon down here, or not a double or anything that's other than single bonds, is this nitrogen right here. So this nitrogen is single bonded to 3 carbons. There is no carbonyl involved, so it is an amine that is right down here. So you would just circle this nitrogen piece right here. That would be an amine. Now this next one gets a little bit more complicated, and you can see why, because it's got this big ring structure that has a whole bunch of stuff kind of happening all around it. And in this case, there's kind of multiple approaches you can take. The key idea for this one right here, and the reason I put this here, is you want to make sure that you group things together by functional group, but nothing can be in the same functional group twice. So what I mean by that is, like, for example, we could say that this is a nitrogen next to a carbonyl carbon, and we could circle this piece right here. And then we could say that this is a ketone and that this is an amine. However, this nitrogen is also adjacent to a carbonyl carbon, so we'd actually want to call that an amide because it's adjacent to a carbonyl carbon. So we would actually group this piece together right here. This would be one amide. And then this would be a second amide right here, or amide. That would be in this chunk right there. So now we've eliminated this whole piece of the molecule right here. Even though this is a ring structure and this is a double bond, it's not a benzene because it's not one complete ring with alternating single double bonds. So this would just be an alkene. We would circle this and identify that as an alkene. This right here and this nitrogen right here are both involved not next to any carbonyl carbons, even though this one is next to a double bond or is double bonded to something and is next to, both of them are actually next to a carbon double bonded to something. Just like the example back here, this oxygen was next to a carbon double bonded, but it wasn't a carbonyl. This is a carbonyl and this is a carbonyl. These guys are not next to one, so this is also just an amine, and then this is also an amine because they are just nitrogen singles or double bonded to things that aren't carbonyls. Okay, it was a bit tricky probably, but don't worry, you should get plenty of practice being able to do this. It's going to take a lot of ideas looking or time just looking at them. I really recommend, if you haven't made the flashcards from that video where I recommended it, you really want to make those flashcards. Now, I do want to point out that you'll notice that with ketones we had to add numbers to it. This is because our naming convention that we have been using isn't actually perfect. And to figure out why, I'll leave you with this kind of idea. How many possible ways can you connect 6 carbons using only single bonds? So if you got a piece of scratch paper around, go ahead and try that out. I'll talk about this again in my next video. In the meantime, though, I hope you have a good rest of your day. If you have any questions, please shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a great rest of your day.